Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on preparing solutions. In our last lesson, we learned about molality. We learned that the molality of a solution is the number of moles of solute per kilogram of solvent contained in a solution. We also learned how to calculate the molality of a solution using information that was provided to us. In today's lesson, we will explain the dilution process. We will learn how to prepare dilute solutions from concentrated solutions. Students, if you are ready, then we will begin by discussing concentrated solutions. A common task in all sorts of laboratories is the preparation of solutions of known concentrations. School, medical, industrial, and other chemical laboratories regularly prepare solutions of known concentrations. Distilled, demineralized, or deionized water is used to create aqueous solutions. Other solvents can be used as well, depending on the solution that is being prepared. Solutions are typically prepared with solutes that are liquid or solid. However, they are occasionally prepared with gas solutes. In order to prepare a solution of known molarity, the solute is first weighed accurately and then moved to a volumetric flask. Water is then added through a funnel. The solute is dissolved by gently swirling the flask. After all the solid has been dissolved, more water can be added to the flask in order to bring the level of the solution up to the intended volume. The water is filled up to the meniscus, which is the marker showing the known volume of the solution. For example, 1 molar solution of sodium chloride can be prepared by dissolving 58.5 grams of sodium chloride in water until there is 1 liter of solution. In laboratories, concentrated solutions are often stored as stock solutions that can be used when needed. Stock solutions are often diluted before they are used. Let us move on with our lesson and discuss dilution. Dilution is the procedure for preparing a less concentrated solution from a more concentrated 1. When the dilution process is carried out, more solvent is added to the solution, which decreases its concentration. However, students, it is useful to remember that even if more solvent is added, the number of moles of solute present in the solution remains the same. In other words, the number of moles of solute before dilution is equal to the number of moles of solute after dilution. Students, what is the correlation between the color intensity of a solution and its concentration? What if the solution is colorless?
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, everyone. The less concentrated or more diluted a substance is, the less intense the color will be. The color intensity or saturation of solutions decreases as more solvent is added. And since the amount of solute per unit volume of liquid is reduced. The same is true of colorless solutions. It is just not visually apparent. Systematically diluting a solution is known as serial dilution. Serial dilution is an important technique in physical science and engineering. Scientists and engineers often adjust the concentration of solutions with which they are working. Students, we know that the number of moles of solute is equal to the molarity multiplied by the volume of the solution. This can also be represented as M times V. The number of moles of solute before dilution is equal to Mi times Vi, and the number of moles of solution after dilution is equal to Mf times Vf. Therefore, dilution can be expressed as Mi times Vi equals Mf times Vf. This is more generally expressed as Ci times Vi equals Cf times Vf. Ci represents the initial concentration and Vi the initial volume, while Cf represents the final concentration and Vf is the final volume. Students, let us try an activity. Pretend that you have 2 liters of a solution that has a concentration of 2m. How much water do you need to add in order to make the concentration 1.25 m?
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. Were you able to answer this question? Let us go through the steps and answer it together. We can determine the final volume by multiplying the initial concentration by the initial volume and dividing the answer by the final concentration. This gives us the answer 3.2 liters. We can then subtract the final volume from the initial volume to determine how much water needs to be added. This gives us the answer 1.2 liters. Therefore, 1.2 liters of water would need to be added to a 2-liter solution with a concentration of 2m in order to make the concentration 1.25 m. In today's lesson, we learned about the preparation of dilute solutions from concentrated solutions and the process of diluting solutions. We learned that dilution is the procedure for preparing a less concentrated solution from a more concentrated one. We also learned how to answer a concentration-related question using the molarity and volume of a solution. This brings us to the end of our lesson for today. Until next time, thank you, teacher. Thank you, students.